everyone. I'm Meredith Ashby, part of the marketing team here at Element, and I want to welcome everyone to the Element webinar series with today's topic, Meet the Founders. I have a couple brief housekeeping announcements before we begin our presentations from our panelists. First, if you're attending ASHG in Los Angeles at the end of October, come find us at our booth and say hi. We would love to meet you. Okay, so we're going to start with some opening remarks from our panelists, which is going to be followed by a Q&A session. You're welcome to submit your questions at any time by clicking on the Q&A icon in your Zoom webinar control panel along the bottom there, and just note that that is distinct from the chat icon. And then finally, we're going to be recording this webinar and making it available for reviewing in the next few days. With that, let me introduce our panelists. We have Molly He, our CEO and co-founder, Mike Previty, our CTO and co-founder, Matt Kellinger, our co-founder and VP Biochemistry, and Sean Levy, our SVP of Applications and Scientific Affairs. Molly, we would love for you to start off. Could you tell us a little bit about the founding of Element?
Yeah, well, thank you, Meredith, and thank you everybody for joining in. In the morning hour, I have my tea in my hand, so this is supposed to be a conversation. So really glad you're here. Instead of me telling the founding stories, I was thinking that, my co-founders, Mike and Matt, should be telling really fun funding stories because, Element is their actually initiation at the beginning. So I wanted to leave the fun to these two guys.
I love it.
I do want to share with everybody that what I think Element stands for. And I think it's actually really important, not only we share our technology and products, but also share our values and behind Element. And I was reflecting it last night, and it's amazing that actually the four things I'm going to talk about is not only deeply rooted in my, Chinese upbringing, but also deeply shared with all of our American coworkers. And it's amazing to see, despite the cultural differences in Chinese American, that there are such amazing similarities here that, that made me realize we're one humankind and doing great things for humanity together. So what are we stand for? Number one thing, work hard. So when I grew up, my mom used to tell me, no work, no cookies. So it's absolutely true, right? So I think we are taking on a very, very difficult task, penetrating a market that is dominated by one player for the past decade. And that's not for everybody. And that really is for somebody who are willing to work hard to make a difference. So I wanted to applaud all of our 325 elements here who made this choice to do the hard work and to make an impact. So that's the number one, what we stand for. And number two, work smart. So work hard is not enough. It's not enough, especially we're in this David and Goliath situation. We've got to work smart. And what that means is that, we have to look at how we maximize the return of our limited resources. That includes capital and also include our time. Nobody's time is unlimited, right? So how do we maximize that? And we not only take this kind of approach internally at Element, but also want to empower our customers and partners to be able to do more with less. And this is actually, really truly reflected in our very first product. That's a DNA sequencer, a VT, that we have best data quality, 10 times better than the leading platform with a fraction of the cost, right? A third of the cost. And this is how we enable and empower our scientists to do more with less. So that's the second piece. And the third piece is stay humble. And this is something like it's fundamentally critical to Element and to all scientists in the world. Knowledge is unlimited. And the old Chinese saying said, if you walk with two other people, three people work together, you will find a teacher within that three people. You will actually be able to learn something from them. So what that means to Element is that we're taking a very different approach to our innovation. That is first principles approach. No matter where we're coming from, we have extensive experience in sequencing or some other field, but what we want to do is remove all these assumptions based on the past experiences. Let's start from scratch. And that actually is resulted in something that's incredibly powerful, right? So that's the third thing I wanted to share. Last but not least is to share. Share freely our accomplishment, share our technology so that we can empower every single scientist, every single lab in the world to do more with less. And what that means is that in our business model, we're decentralizing sequencing today, and we will be decentralizing other powerful tools in the future. So that, maybe wrap it up, and that gives a segue to the next few panelists.
Yeah, absolutely. That's really inspiring. So Molly, since you suggested that your fellow co-founders might have the most exciting co-founding stories, let's move over to Mike. And Mike, can you walk us through some of the foundations of Element Technology and what really makes it unique? And if you want to throw in a humorous founding story, that would be amazing too.
Oh yeah, no problem. Let me, maybe we could start with some slides and sort of bring those up and kind of talk through those.
So we presented a few of these slides probably at AGBT, also at our original launch event, but
review is always good and repetition is always good to keep themes moving forward, right? So just to, review, one of the things that we always talked about, Molly just did talk about, is really providing affordable sequencing with no trade-offs. And in order to do that, we really wanted to be able to provide the highest data quality, the lowest cost, the drastic decrease in capital equipment costs, and for the customers to control their science. Now, there's a lot of different companies that are actually on this plot, actually most of the sequencing companies, but one of the things that we didn't point out, we wanted to emphasize, is that this is where Element stands. And really for us to drive our price per G down is really part of the embodiment of the system itself and the chemistry that's been used. So really our scale is based off of the innovation that we put into the technology, not in the size of the economics of scaling up the technology. So what does that mean for you as a customer? Well, what it means is that if I scale up or down in throughput, I can still provide you the same cost per gigabase. And this is profound. This is a profound difference in the sequencing field and something that we really are proud of. And we hope that you as a customer will benefit as we grow as a company and become one of the companies that you guys trust and rely on for your sequencing output. And again, just to review where we are, I always have a little marketing hitch here. Our instrument is at $289. It's basically dual-sided. We have a price per run of $1080 for 120 gigabases. That'll be released in Q4. That's a 2x75 kit. And then $1680 for 240 gigabases. That's a 2x150 kit with a data quality Q30 greater than 90%. So we're really setting the standard without trade-offs. And our technology at this point is well developed and well established that we're able to provide this when you receive the instrument and it gets installed. So how did we do this? And really kind of going back to what Molly was saying, we really took a first principles approach to all of these elements. The surface chemistry, the sequencing chemistry, the instrumentation, the base calling, the amplification, and the workflow. All of these things are intertwined. So if you change your surface chemistry, ultimately you have to change the formulations that you use or the sequencing chemistry or how to deliver things for amplification. If you change your amplification chemistry, then you have to make sure that the sequencing chemistry works with that new amplification technology. So because of that, and because of our innovation, we had to understand everything from ground up. And to Molly's point, the hard work was really us being able to figure those things out. And I will say that probably, I don't know if what Matt will say, but the hard work behind that wasn't always fun in many instances, but maybe towards the end, we'll have some more fun stories. So really just showing kind of that hard work. This is what we originally looked at for our amplification chemistry. We spent a lot of months, maybe a year, trying to figure this out with one of our founding scientists. Sanan, and really we were a little bit dismayed that this is how it was going to look. But ultimately, we were able to figure out a technology here that allowed us to deliver the high quality and high performance sequencing that you see today. And this is really something profound and really Element innovated in order for us to be able to do this, especially on a low binding surface. And then really this is it created opportunities in decreasing optical duplicates and also undetectable index hopping, which we think is an opportunity for the field. We know the field has moved away from, it moved into dual indexing in order to get around this problem. But now that this problem doesn't exist on our sequencing systems, it'd be interesting to see the opportunities that we can open up here. And then the sequencing chemistry is very novel indeed. It's really something based off of avidity. Avidity is a technology that's been actually used in the drug industry in a number of ways in order to increase the binding affinity of drugs to their targets. And by doing so, they bind in multiple spots. And this creates a lower requirement for the amount of reagent that's used or the amount of drug that's used. And this is how we can fundamentally drive the cost of the chemistry down. In addition, some of the additional benefits, the ability to mask phasing and pre-phasing, as we've talked about before, and this really helps retain a high signal to noise and quality that Sean will probably talk through in some of the data that we've presented and worked with customers on. This is the workflow. As you see, there's an additional step here. It's to bind the avidites, the wash, the detect the base, the remove the avidite, and then step with the block, and then remove the block. So this is adding a little bit of an additional workflow. But in addition, the benefit of this is that you could actually consider yourself doing multiple reads up front. And with the low concentration of reagent that we're using for the detection step, this can be spanned to many different applications. And we can talk a little bit about that towards the end. And then ultimately, the instrumentation is really state-of-the-art in the field of microscopy. It's really a system that has a very large field of view and really incredible edge-to-edge performance. Combining this with a proprietary algorithm that's done onboard processing with a processing system that's been proprietary to Element. We've had filings and issued patents in this area, has allowed us to scale up the densities into a really sort of state of which hasn't been seen before on a random flow cell. And then this is just a brief look, and I know a lot of people have seen this, but we'll bring it up again. We're really pushing unprecedented, well-calibrated data quality out to Q40. Sean could show the relevant applications of this, but we have this data available for download. And this is also one of the things in terms of humility. Element's a very transparent company. We're very transparent with our data, and we're very loyal to our customers to be able to make sure that this is what they're getting. So you can be sure that if you're not seeing this kind of data quality for your PCR-free libraries, we're going to be there to make sure that you find the opportunity to see that. And then this is a slide that we showed, I think, at AGBT, but it's still really important, especially as we come out with our 2x75 read kit. You're going to see here that as you scale up the number of reads, which is 1.3 billion, you have an opportunity now to really achieve price per million reads that's unprecedented in the market even today. And by doing this, we don't feel there's not a huge sacrifice in data quality, but there is a huge gain in the number of reads, and especially for the applications that are 2x75, this still gives you plenty of headroom in terms of data quality to continue to drive that price down on your instruments beyond this product specification, which is 800 million reads. And then as I talked about earlier, we really have ultra low optical duplicates and negligible index hopping. This is a huge advantage to the system because it increases the actual amount of data that you're getting off the system versus the data that you have to throw away.
And then finally, there's been a lot of questions about, well, what is the maturity of Element? Well, one of the things that we go back
to the hard work mentality, we really knew that we had a time that we had to meet. And that time we had to meet wasn't just to meet the technology advantages or the technology specifications, but we had to stand all that up to be prepared to put the manufacturing, consumables, and instruments in place such that we weren't short on supplies and that we were ready and mature enough to go into the field and support the instruments. So this has been in the works for over a year. or more, maybe a little bit more. And by having that, when we hit the field, we are prepared and we are a mature company to be able to stand up service and support and to have instruments and technology that is ready for the customers to use reliably. And of course, we are shipping today, so that was something we figured would be important to add. And then finally, to Molly's point about working together, we really have quite a bit of technology here, especially with the surface chemistry as only an example. And by having this, we think that there's opportunities that are opened up for us to work with partners and collaborators to use the chemistry to deploy what they might be interested in for specific assays. And these are just some examples of that. By combining that with the Avidity chemistry, we have huge flexibility to work with people and to be able to deploy assays that they might be interested in using on the Avidity system itself. And all of this data was collected on the Avidity instrument. And so we just want to specify that we have a lot of opportunity to expand the breadth of where we can go with Element Technologies. And I think that's it. Let's see if there's any other.
That's fantastic. You know, I've heard all of this before, but hearing it all at once in one place, it really blows my mind how much innovation in so many different areas had to come together and align in order for the instrument as a whole to work as amazingly well as it does. And this is a question maybe for you, Mike, and also for Matt, who I know was instrumental in driving a lot of those chemistry developments and inventions. Was there like a moment when you were like, oh, wow, this is really going to work? Like late night or?
I mean, I can speak to that a little bit. I think it's interesting, you know, when you start a company, maybe others have experienced this before. You've got a bunch of ideas on a whiteboard, and then you have to start putting those ideas into practice, and they don't all work, right? And you really learn sort of who you are, and your company, you know, learns a lot about itself as you go through and iterate through, you know, problems that on a whiteboard aren't problems, right? You get in the real world in the lab, you find out things don't work. I think what we did, you know, really well was, you know, stayed tenacious to work through a lot of the early issues and had to pivot to Scheme B and Scheme D. And, you know, as we got further along, we started to solve each of the pieces. We started to see how the whole system can come together. And I think in the end, we developed a platform that even, you know, surpassed what our initial expectations were and, you know, still has headroom beyond that, right? So that's very exciting, you know, as a whole. You know, the individual pieces of the technology, they all had to come up together, right? So, you know, you can't work on an amplification chemistry without a surface chemistry. You can't work on a sequencing chemistry without Polynies to begin with. So, you know, in a sense, each piece of the technology pushed its neighbor to get better and better. And, you know, where we ended up with the VT for the first product, I think is quite an accomplishment, you know, at the beginning. And I also see lots of room for future growth.
That's fantastic. So I recently joined the company, and one of the things that I asked everyone that I interviewed with is, are there 3 words that really define Element to you? And I was so impressed and inspired that the one word that came up over and over and over, actually almost everyone said it, was grit. And I was like, I want to work with those people. All right, so let's move to our next speaker, Sean. So Sean, we've heard all these details about the amazing capabilities of the basic technology, but of course, you know, we have lots of scientists on the line listening, and I know that what they want to know really is, what can I do with this? What problems of mine can I solve with this? And so I'm going to bring up some slides here and have you talk us through what kind of applications are you most excited about on Avidity?
Well, so I think, thanks, Meredith. And I think the application space is critically important to keep in mind as we look at a sequencer. You know, as Mike presented, the paradigm in the field has always been to increase output at a rate that is faster than the increase in cost. But the one unwavering detail of that is both have always increased. And that has had an amazing catalyst in the field of allowing people to really think broadly about genomics, truly genome scale, which, you know, at the start of my career and the start of, I'm sure many on the line's career, the idea of routinely doing human genomes and human transcriptomes, et cetera, was really just a fantasy, and here we are a couple of decades later where, we truly have that reality. But what that's done is really uncovered that there's a tremendous amount of complexity in understanding the genome and really applying that understanding to make products better, make healthcare better, make our ability to live healthy lives better. And in that evolution, I think we've certainly also realized that there is going to be no single path of discovery, no single path of understanding. And so transparency and efficiency in work and willingness to collaborate will continue to be extraordinarily important. And what's shown on the slide is really just, I think, a synthesis of a few highlights from my career that have really underscored this, whether it be in forensic biology or forensic sciences, which is shown on either side of the slide, to many interesting human phenotypes. Some things that have shown us the complexity of what happens with the two women in the middle of two different mutations, but yet in the same gene and vastly different phenotypes, to the ability to impact pediatric cases to, in truly life-saving events. And I know that this is certainly not a unique experience. This renaissance in biology and genomics has allowed many investigators to experience the amazing personal and professional gratitude that bringing these advancements forward has. And I think what Element's done now has made this accessible and able to be democratized in an extremely high quality methodology and an extremely high quality technology, which of course the methodology and the technology are two different things. The foundational technology allows us to innovate on those methodologies, which is what I'll touch on in a few of the coming slides. And I think anyone that's seen me speak before has seen these. I think most of my career has been spent in pediatric oncology and pediatric rare disease research. And we understand, certainly when I transitioned to the Hudson Alpha Institute was shortly after my first son was born, and I've used my kids as a mechanism, one, to test ideas off of, because if they can understand it, then it generally means it's a good idea. And secondly, as a reminder of how quickly these technologies change. And that's both a reminder of not only the evolution, and this is just through different vignettes of sequencing through my laboratory over the years, ending in 2019. And stay tuned for an updated picture of these two at the Aviti platform in the coming days. But the bottom line being, it's also a reminder that things do change fast and innovation has to keep pace, meaning that a personal motivation of mine is to be sure that I'm continuing to move forward to drive change and drive a difference at a speed that outpaces even the pace that we see that every parent experiences as their kids grow up, that they grow up very fast, and we see that change. So this is just, for me, just a personal reminder and kind of a timeline setter to how we always have to be looking at technology to be better. There's no reason to stagnate and stick with single technologies. So we go to the next slide. So with that in mind, I think if we orient what you heard from Mike and the introduction from Molly, and as Matt mentioned on some of the challenges of developing these foundational technologies, if you look at them now in a little bit of a compartmentalized approach of looking at the detection chemistry, that there's, as Mike briefly mentioned, there's a diversity of biological applications from antigen detection to cell analysis that are captured on the same platform, to class-leading costs, even for applications that are very read density heavy, like bulk transcriptomics, whole exome sequencing, or even whole genome sequencing. That along with that, we want to have a longevity of the equipment, and longevity just not in the sense of how long a platform is relevant, but how reliable the platform is while it's running. That we want that longevity of the platform in terms of its confidence and trust, that you rely on it to answer the most critical questions that are under study, and trust it to be a good steward of limited resources. And finally, data quality is everything. And we had no goals of setting, a platform into the field that delivered the same or worse of what the state of the art was. That wouldn't make sense. That doesn't move a field forward. So what does move a field forward is demonstrating a data quality that makes a difference in results. And I'll show a couple of brief examples of that in the next couple of minutes. But we also wanted to mention that the platform it has been validated on a wide variety of applications, not just sequencing. And so in this case, and I'll go through these next couple slides quickly, we have app notes and data sets available on the website to go into more detail, but we validated for things like proteomics, in this case, working with Olink. The next slide will show a similar thing with 10x Genomics working with single cell analysis. So the diversity of applications that is supported on the platform is complete. Anything that's in the field now is able to be run on the platform. These are two examples of commercial partnerships and commercial applications where we have data sets available for public consumption. But again, the point being is that these are ready to run. As Mike's mentioned, the platforms are shipping today. We have installed base in the field. And then we've even been able to show if you push the limits of the platform, you can do some pretty encouraging things at a convenience and a throughput that is exceptionally enabling. In this case, in collaboration with some investigators at UCSD and hard work done by many of my colleagues here at Element, show that it is absolutely possible by pushing the output of the machine upwards a bit, in this case to just over 1.1 billion reads, but still maintaining Q scores greater than almost 95%. We can sequence the equivalent of 330, actually just above 330x genomes per flow cell. In this case, in that previous case, the probands was intentionally sequenced deeper than the parents, but if you add up the 51 plus the 21 plus the 20, it's just over 90x. And so it's absolutely possible to sequence 3 genomes per flow cell. Wanted to kind of draw that line in the sand of what's possible on the platform. If we go forward one slide, we can orient that to exome sequencing, and importantly, orient that to exome sequencing on the soon to be available 2x75 kit. What this allows is an efficiency and a cost point in exome sequencing that does not require batching of hundreds of samples. So on the table on the lower left-hand corner, realize it's a little bit of a complicated table. I won't go through line by line, but just point out that just over specification, and then here, if we push that specification upwards to the 1.1 billion reads that you saw on the previous slide and demonstrated with the table that's highlighted in green on the upper right-hand side of the slide, we're at a $45 per exome sequencing cost that's competitive with the NovaSeq S4 pricing at $41 and certainly exceptionally enabling against any other benchtop sequencer. If we look at data quality highlighted on the upper right-hand side, note that the Q30 scores on this particular run is at a full 97% with a duplication rate hovering around 2%. Our coverage at greater than 30x coverage across, or greater than 50x coverage across the exome is at almost 90% with a fold 80 penalty of 1.3, an exceptionally performing data set. If we go forward one slide, you can see that this is not a golden run. These are specs we're able to achieve on both a fast hybridization as well as a standard hybridization setting, in this case done with Twist. And so we can do this on multiple samples and do this repeatedly over and over again, as you see here in these demonstrated plots. So class-leading exome performance without the requirement to increase cost per sample or increase throughput to hundreds of samples. And then finally, we know variant calling performance is very high, and our ability to generate to leverage those Q40 scores and high Q30 scores to meaningful results is critically important. What this slide shows is a summary of some data on HG005, a genome with a true set available, showing that even at low coverages, we have about 50% fewer total errors compared to competing platforms. And what we're really now working hard to understand is to fully appreciate from a starting point of sample input all the way through to final bioinformatics, how to leverage that improved data quality to have 30x or better coverage performance in terms of variance at much lower coverages in terms of efficiency of sequencing. And we're working with a number of partners on this. Essentially, what's highlighted on the slide is that the delta between the error points at 30x and what we see over at the 20x point. We're look forward to releasing more data on this soon. And finally, one other point is our significant ability to do low diversity sequencing and have high performing assays like methylation analysis under conditions of either bisulfite treatment or enzymatic conversion of non-methylated Cs, essentially taking what is a 4-base genome and turning it into a 3-base genome. Exceptionally challenging for sequencing. The team at Element worked very, very hard on this, both from a software side, from a chemistry side, and of course from from the ability to generate libraries. What's shown on the left-hand side of the slide is where we were using a 30% Phi-X spike, and you can note the pass filter rates improving from 86 to 96% when the software team created a low diversity pipeline. And then with continual optimization, not being satisfied with that, the requirement of continuing to use upwards of 30% Phi-X, even though the performance was strong, the team asked, is there a way to make this better? And that's what you see on the right-hand side of the slide. Note that the pass filter densities are above specification. That essentially equates to approaching about 900 million reads. Our pass filter rates are hovering around 94%. And note that Phi-X is essentially optional. So whether it's 0%, which is shown under where it says NA, a 2% or 5% target, we're not seeing any appreciable suffering in the Q30 scores, all maintaining things in the 95% range. Of course, the subsequent question is, does it work? And that's what's shown on the next slide. And under control experiments, we can see very good performance for alignment metrics. And then on the next slide is how does the methylation detection look? Our expected was 53% in an NA12878 cell line. And you notice across 3 replicates on independent runs, we see the expected just over 53% methylation. A key question is, how does a negative control look? And that's shown on the next slide, where we see, of course, 0 spurious detection of methylation in these control samples. So it shows that even that feature of using a small amount of Phi-X in these experiments truly translates to a benefit in terms of the efficiency of the experiment, and we're able to generate this highly accurate data in a very challenging condition like methylation analysis. And then finally, we see this consistently, and we see the same pattern that Molly mentioned earlier, 10 times improvement in sequencing quality. This is shown it with some work with collaboration. We see this run over run, and I'll just highlight that the element run shown at the top, an average Q score of just over 41 compared to the same libraries run on a competing benchtop platform, which is shown with average Q scores around 31. So we have numerous data sets to back up our observations that our Q scores hover in the low 40s versus competitors that hover in the low 30s, really setting a new benchmark of achievable Q scores under appropriate library conditions. And lastly, does it, when you collect this all together, does it make a difference? And the answer is yes. And you see this in 2 things. One is we're able to achieve appropriate low allele frequency detection, as you see on the plot on the left-hand side, showing correlation between runs on a NovaSeq versus allele frequency detection on Element for low frequency variants. And then something that we see in numerous data sets over and over again is very simple. The higher quality data results in lower false positive rates, whether it's Mendelian inherited disease detection or somatic detection, as it shows in this case. Note the difference between the number of false positives shown in blue, which is a competing platform, versus green, which is the Element platform. We see this again and again in various data sets. In this specific case, we're showing it in somatic variant calling. And lastly, we also know that we have fewer errors through challenging regions of the genome. Shown here is just an example of sequencing through dinucleotide repeats or long homopolymers. In the interest of time, I won't go through these figures in a lot of detail other than to say, simply note the contrast on the left-hand side of the screen, which is competing data, versus the right-hand side of the screen, which is Element-specific data. As we said, full transparency, these data sets can be made available. We're happy to have a deeper dive on any of these discussions with anyone who's interested in seeing this data in more detail. But again, note that from a final results perspective, when you're incorporating alignment and other features, the data is just much cleaner, which is what leads us to those better indel sensitivities, lower false positive rates and variance calling, and an overall higher efficiency to the data set, almost regardless of application. And lastly, also wanted to mention that we have an amazing technology through an acquisition of Loop Genomics, which is the LoopSeq, which is a linked long read technology. It's a very elegant molecular biology that allows us to characterize samples that are between 1 kb and probably upwards of 7 to 8, maybe 10 kb. You're only limited by a long range PCR, and we are able to then analyze those molecules, whether it be for HLA or full length 16S or immune repertoire or metatranscriptomics and transcriptomics and a variety of cell manufacturing and other fields. it's a very elegant approach. And if we go to the next slide, we have a large number of publications that the Loop team has generated with collaborators over the years. These are just the 2021 publications. Again, welcome the opportunity to exploring this technology more, but it's an amazing complement capability for Element to have this as part of its feature set, allowing it to be really the first commercially available platform that allows both short read and long read applications from the same company on the same platform.
That's terrific. Thanks for sharing all that. Just the sheer wealth of applications that have already been evaluated and partnered in testing brings to mind a second word I heard a lot when I asked people about what does Element mean to you, and that is transformation, right? And Element is just a company full of people with big ideas who know how to solve problems, which is a really exciting place to be. Okay, so with that, I would like to go to some of our Q&A questions. But let me start with one of mine to get us started out. Sean, as the only non-founder on our panel, why did you decide to join the company?
Because Mike adopted me. No, I'm kidding. So I've had a very fortunate career spanning just over 20 years in academic research and development, primarily running core facilities. So that gave me an exposure to literally thousands of projects. And we were fortunate that the success of those projects with grant funding and other things allowed us to build a very large genome center. And through that allowed it to be exposed to a wide variety of technologies. And I think it was really two reasons to join Element. The first is always wanted an opportunity to be able to continue some of those innovative experiments with the ability to access the underlying technology, not just be a customer, but really be having the ability to help drive some of that technology forward. And the second being that as I got to know the Element team, and it really all the things you've talked about in the words that you heard as you were interviewing with Element and what we've heard from the three co-founders resonated very, very well. Essentially not being satisfied with not only the current state of the art, but recognizing that internal reflection of always trying to be better and looking for those opportunities to make a difference. And those are very easy things to say, but when you actually get to experience it, and of not just the founders, but when you realize that there's a team of 300 people that are all aligned in that same direction, it makes it a very inspiring place. And so I was certainly honored to have an opportunity to join the team. And it was one of those, I think very rare occasions in life where you see an opportunity that you just say, this is an easy decision to make. And although it was certainly a substantial change in direction for myself after a long time in academia, I really saw it as an opportunity to continue forward of really trying to make a difference. As I mentioned with some of the examples in the pediatric examples I've shown, this is just a new evolution in how to be able to make a difference there.
Absolutely. Okay, so I'm gonna paraphrase one of our questions that came in from the audience, and the question is, with this technology being so new, what do you see as ways that the technology can grow and evolve to engender even better performance? And Matt, maybe that's a good one for you to take.
Yes, thanks, Meredith. I think the first product being on the market is extremely competitive in the space. Sean and Mike just went through, a lot of that details. We really felt like it was enabling. We also feel like it still has a ton of headroom to move forward, right? So, right now across the hall, there's 100 scientists and engineers, all working on, the latest enzymes, the latest substrates, new surfaces, new analyses, new workflows that ultimately, expand the reach of the platform and we'll get better and we'll get faster than we even are today. So, with a lot of headroom comes a lot of excitement about what we can do on the Aviti platform, in the future.
That's awesome. That's awesome. Another one from our audience. Since this is the first version of your instrument, people may be skeptical to switch from Illumina to Element Biosciences. What is your vision for the next 5 years? Are you going to have a newer version next year and this will be obsolete? Is the instrument going to be upgradable?
I think what we're not gonna, put out a new instrument every year. That's not part of the play. We want to expand the breadth of the applications that can be done on the system that we built. And we spent a lot of time building it. There's a lot of innovation in it, and we think the innovation should hold us for the next 3 years or so, or longer. And that's something when you're planning to what you're going to build, you got to think, how long is this going to last? And so we want our customers to be able to use the instrument for what they're doing today, but to expand the breadth of applications that can be used by innovating with a lot of this wet chemistry, to be able to give them that opportunity to do that. So 5-year plan would be able to increase the performance, as Matt has just talked about, especially in the areas of speed and quality and cost, but also to increase the breadth of the applications like Sean was in loop area, and potentially other applications that we showed that we have the opportunity to do because we studied from first principles all of the technologies we have.
I'd say, Element was the first company to embrace what came before it in the ecosystem, from library preparation all the way through bioinformatics, showing a commitment to moving the field forward. And I realize that doesn't necessarily address the question, but I think it really shows the philosophy behind the platform, and that is to embrace what came before it, use that innovation to the advantage of the field. And the platform will certainly evolve. But as you saw in some of these early vignettes, and as Matt mentioned, tremendous amount of headroom on the platform. We've shown some other applications that the chemistry and the underlying optics can produce. So we have the utmost confidence that this sequencer will be relevant for the long term, and there will be opportunities to add on applications and add on capabilities, through continued partnership and investment with Element.
Okay, now we have one that's a bit more technical. One of the data sets that Sean shared, I saw that the duplication rate was only 2.7%. Amazing low duplication rate. And then I have 2 questions about this. 1, what library prep method was used? And 2, is there a similar step with Illumina cluster generation for Aviti sequencing? Why does that not happen on Illumina?
Yeah, so the quick answer is, so Element uses a rolling circle amplification. And on the slide that Mike showed, where there were 4 different Element applications that all illustrated low optical duplication rates, it's inherent to the underlying chemistry through the Polyny generation and that amplification. It's stated very simply, and I realize that making simple statements is dangerous in science, but it's, in the interest of time, it's that there is not the same opportunity because of the foundational chemistry and amplification methods used to create chimeric molecules and end up with copies of copies and end up with index misassignment. Those are all related to each other. So we're just fortunate that the methods that were developed from the 3 founders and the rest of the Element team just allow that advantage. The duplication rates are very low, and it's something we're particularly proud of. In fact, I think this platform has revealed that the level of optical duplication rates that is observed in the field in general is probably a bit higher than maybe was expected, and that the library preparation, while also a source of duplication rate, perhaps was the unintended victim of many of those assumptions as to where the distribution of duplication lies. Now, as far as the prep in the exome example, it was a standard Twist library prep. Their commercial product and their Twist 2.0 exome was used in that example. As I said, that is an upcoming data set that we'll make publicly available, along with more of the details of exactly what was done, how much input, et cetera. So again, we'll share that with the community at large very soon.
Awesome. So we have several questions on this topic. The cost of annual service contracts remains a huge issue in our shared resource facilities. Can you tell us about your instrument support and service contract agreements?
I guess I'll take this on because we don't have our CCO here. I'll be the fake CCO. So the service contract currently is at $20,000, I believe. And I think the first year comes with the instrument, so it's all included the first year. In the second year and on, you pay additional $20,000. And I will say we have a very, very strong service and support team. And I don't know if anybody joined our virtual launch or AGBT launch. We actually specifically mentioned our launch is going to be metered. What that means is that we are releasing only set amount, definitive amount of instruments to the field by tranches, just because we want to make sure all of our early customers are successful. So, we have, very small but mighty service and support team. And we actually want to make sure every single early customers are supported by at least, by at least 1 or 2 FSEs or FAS so that they are successful. And, knock on the wood, so far, the instruments in the field have no problems at this point. And I think maybe Mike and Sean can add a bit more color to that. We are very pleasantly surprised about, the stability of our instrument in the field so far.
Awesome.
Yeah, so there's we should just mention there's 30 instruments that run within Element on a daily basis, and so we do have good statistics on long-term reliability, and those instruments have run approaching 15,000 runs over time. So the service and support team has been able to get well experienced within Element and learn the ins and outs of the machines. And I think what this shows is, as everyone I think has experienced, the beta program was very short, and then the time between the beta program and commercial launch was also fairly short. And that was intentional. The instrument was quite mature when it came out. And then post beta test, there was a few reliability changes made, a couple engineering changes made to accommodate the machines that have been shipped. So that reliability we've seen in the field is really not unexpected. We of course had to empirically test that, but it's a well-worn path that started with the original design of the machine. It speaks to the care and attention to detail that the engineering and software teams have paid to this platform, in their development. It just shows I think the dedication of the entire group.
Fantastic. So we have a question now from a cancer researcher in attendance. How is the performance of the avidity chemistry on poor quality samples such as DNA from FFPE embedded tissue? And maybe you could approach that from maybe a larger opportunity to talk about your vision for cancer research and cancer specific applications on the Avidity.
Yeah, so it's the performance has been very strong, and the reason for that is, as Mike mentioned, it's a multivalent approach, and so when you have base damage or base adducts or other things that may affect the an error rate in library preparation, which the sequencing quality is high enough that we didn't show this, but we've shown this in previous presentations, that the sequencing quality is high enough to detect some of that error that's introduced at library prep. You can do much the same thing during sequencing. And what really drives that higher quality in terms of detection of the base are those foundational chemistries and foundational enzymology that the team has come up with. So that multivalent approach allows you to sense multiple nucleotides simultaneously in that trap step that Mike showed earlier. So if there is, say, one of the positions is an error and the other positions being sensed are not, you still get an accurate base. So we also know that the platform is very efficient with the amount of library that's loaded onto it for the amplification done on the system. So far in the oncology specific data sets we've used, which has spanned a number of applications from fragmentomics to cell-free DNA to low frequency allele detection, both in control samples as well as real samples, we've really seen exceptional performance, and we've seen the leveraging of a lot of the statistics and features that we've illustrated today really coming through as benefits, and particularly in that low noise that we see in the final data set, lower false positive rates, more sensitive allele detection rates. And we're working quite hard on some more data sets to really show these things in the context of some biological assays, where we can show a true result. We really wanted to prove that the technology works, and now we're looking forward to we want to get it out in the field and in the hands of more people so that they can demonstrate the same things. We also want to be mindful that Element can't do everything all at the same time, for everybody, and so we're hoping that these example data sets will provide the trust for someone to take to move or put trust in Element to move their research forward.
Yeah, just to push on that one more. I mean, especially for the researcher that asked the question, because of the performance of the system in terms of the quality that comes off for a PCR-free library, it really allows you to screen your preparation process, right? So because of the fact that that preparation process basically deteriorates the quality, you can actually use the sequencer to actually improve your process to get better quality because the quality is so high, at least we know it to be. So that's an opportunity that we're hoping people will start to use the system to really make the front end of these things a lot more robust.
John, too, I mean, your team's done a lot of testing. I mean, if the QC from the library looks good, the performance on the sequencer is there, right? So
It is, yeah. You know, as Matt mentioned, obviously the upfront, really, I would say, we know that going all the way back to how you isolate the nucleic acid, particularly in oncology samples, how you treat an FFPE sample, for example, is critically important to the final results. You know, we have been taking a very holistic approach with our partners and collaborators on this. And then I think the other thing you'll see, just this summer, we're working on data sets to take library metadata, not just how much library, but the concentration, the size distribution, and developing methodologies that where the sequencer will help the researcher load it optimally so that you can generate those data sets in a very optimal setting. And so we are very much looking forward to getting out these sort of front end and back end supporting tools. We're not trying to reinvent the entire ecosystem, but again, the theme is we're trying to make that ecosystem better, and that includes tools to support researchers with those challenging samples, where you can input information about the sample, and you'll have a dynamic guidance as to how to load the sample for optimal results.
That's great. We have a number of international attendees on our webinar, and a lot of them are asking, I'm in Thailand, is there a service provider? I live in Europe, can I get an instrument? Maybe you can talk about the plans to expand the commercial footprint beyond North America.
Yeah, great question. We actually got a lot of these inquiries ever since we launched. I think one reason being that, we are providing the best data quality at a very much lower cost in a decentralized model is very attractive to countries outside the US. So to answer this question, this year we will be actually focusing on the US, but we are planning to penetrate outside US countries. And we will actually share our plan in the coming months.
That's really exciting. Here's a question from another listener. Great work. How long does it take to go from sample to result for some of the typical protocols? Any thoughts on what sample prep innovations might be on the horizon?
So anywhere from 19 to 48 hours, depending on the sequencing conditions and the amount of data collected. And actually, Matt may know if it may even be possible to be faster than that.
I mean, I think it's very dependent on the run configurations. That question may have also been on the upfront sort of library prep, right? I mean, I think we're compatible with a lot of standard applications that are out there today. The idea wasn't to really reinvent library prep in any way. It was really leverage a lot of the great brands and great technologies that are there. So there's that front end of the library prep, and then the sequencing for the full 2x150 is 48 hours.
Yeah. And I'd say on the front end library prep, we've had announced efforts with Volta and Miraculous and some of the microfluidic approaches, as well as Sequel and some of the others that use a transposase-based library preparation to make that time from sample to library much faster. And then we have a number of automation partners to try to streamline that from a scalability perspective as well. So we've really tried to have a very broad breadth of relationships and partnerships to make sure we have the ability to capture a wide variety of applications and experimental designs.
I think sort of equally important is the back end. We don't have the software and the bioinformatics teams really represented here, but the idea was the data can go anywhere customers want it. So there's also a lot of connectivity on the back end to be able to run downstream applications and analyses much more seamlessly. There's not a lot of moving of huge data sets and complications on that, right? It was designed to work simply.
Awesome.
Yeah, that's a good point. I also mentioned that the instrument is standalone. There is no secondary computer that's outside the platform, and so other than a network connection to allow data to go out to your data storage place of choice or cloud resource, it's a self-contained instrument. So that's been another area that the software team and the engineering team spend time on, is to have that efficiency and ability to be compact built in.
Awesome. So we have time for one more question. So I'm gonna pick one that's maybe a little more philosophical and let all of you have your own answer here. As founders, as you expand your lab applications and people management and commercial footprint, what tools are you using to stay focused on your company goals and not be bogged down by the day-to-day? Sounds like we have an entrepreneur in the audience.
Who wants to go first?
Well, I think you're probably the best to take that question
Uh,
because we're not that focused. I'm just kidding.
Yeah, I think that actually goes back to what I mentioned at the beginning. First of all, we've got to put in the hours, like work hard. And the second is it work smart. And that also means that we've got to prioritize properly, really put effort and limited resources on the most critical, important things. And I think, for all of us sitting on the panel, the most critical things might be different for each of us. I think for me, and definitely from my personal view, is really making sure we are strategically sound. And I'm not really just looking at next quarter. I'm looking at 5 years out. So I think that's really important. And how do I have time to think about strategic things? I actually carve out 30 minutes every day, just block my calendars, like this is my downtime. I'm going to think it through. I'm going to, spend this time to really think instead of just kind of rushing through things. So.
Anyone else?
Yeah,
You should have a plan.
I think it's not just it's not just a plan. I think this is something that Mike preached from the beginning, really is, have a plan A that you think you have a lot of confidence of and the goals are high, but also have a great plan B. So if you have to pivot to plan B, you like that plan just as much. And I think, that's a way to cover a lot of ground quickly, right? So I think we still try, to do that in a lot of places, and that keeps a lot of the options open. You can really pick from the best of, the options you have. So in R&D, I think that's sort of a philosophy that we try to approach things by, always have, multiple good options.
That's fantastic.
I guess I'd just comment briefly that I think, in my career, it's been exceptionally inspiring to get to work with so many different investigators, right? And so I would say that it's not so much in getting bogged down in the day-to-day, it's really taking time to really appreciate the diversity of ideas that come in from those collaborators and from those connections, and really appreciating collectively how much thought and dedication goes into really anyone in this space, and in your earlier question about asking, why joining Element, when I look at it from that direction, I'm just, I could almost ask it the other way, right? I'm thrilled that Element chose to have me be part of the team more than, as much as me joining them. And I think that, that sort of philosophy and environment and really trying to appreciate the field at a whole it may sound as a polar opposite to how do you stay focused, but I think that, again, casting that broad, net of watching what's out there and really appreciating the ideas helps with that a bit.
We're honored to have you, Sean.
Yes, we are, Sean. Yes, we are.
Yeah.
Awesome. Well, that's all the time we have for today. I want to thank you so much, Molly, Mike, Matt, and Sean, for sharing your expertise and your story and your inspiration. And I also want to thank everyone in the audience for attending. I know we weren't able to get to all of your questions, but I hope you take that as an invitation to come find us at ASHG and ask them in person or one of the other events that we're attending this year and next year. So we have recorded this webinar and we'll have it available for download and reviewing in the next several days. Keep an eye out for a follow-up email with a link to the recording. And you can stay up to date on all of our upcoming webinars by visiting and bookmarking www.elementbiosciences.com/events. So thanks again for joining us today. And I hope you'll join us again for a future webinar. And with that, take care and have a terrific day.